right, welcome to the 50th day of school. All right, I threw a lot of stuff at you last class. I didn't give you homework. You will get some homework today. It will be a mixed bag of matrix operations to play with. Also, I'm going to be assigning you a set of IB problems. They'll be due on December 10th. Okay, so you have some time to do it. That's not to say that they should wait until December 9th, because if you do that, you will drown. Okay, these problems take time to work, so please take them seriously. I'll be posting that on Fusion. Yes? Maybe the last 2 or 3 might be material in the next coming week, but still plenty to put your brain around in the meantime. Going back to, all the way back to sequences and series. Okay. All right, there's only a little bit of new material I'm going to throw at you today, and we're just going to talk about what happens when you play around with a larger matrix than a simple 2x2, and learning how to take the determinants and whatnot for a 3x3. All right, now, so to take the determinant of A, B, C, D, E, F, H, J, K. All right. What we do is we break this large matrix up into 3 smaller matrices that are called minors. So I'll just write this out and and see if you guys can see what I'm talking about. See what's happening here. See if you can notice a pattern that's occurring. Okay, and notice my signs are changing, positive to negative to positive. Now what we're going to actually do, and I should have said, I'm going to take the determinant of these. By the way, there are 2 notations that are used for determinant. There's the DET prefix operator, but there's also an absolute value bar. And I should say, I'm taking the determinant of each of these. So this boils down to A EK minus JF minus B DK minus HF plus C DJ minus EH. So there's a lot of arithmetic in finding these guys, but there are some interest. What was that? Oh, sure. So there's a classic problem that I love to throw at this type of arrangement. Now, do you guys remember what was the term when a matrix's determinant was 0? Singular. So, yeah. if you have any matrix, okay, however large it is, as long as it's square, okay, we can take a determinant of it. And each column gets every other row. The derivation of that requires a lot more linear algebra than we can touch on in this class. If you are particularly interested in it, if you're interested in linear algebra, which is a really cool field, it's the kind of thing that IAs are made for. You know, that's a great place to explore. And if you are interested in it, I've got lots of material on it that's within grasp. It's not like, you know, graduate level or anything. But linear algebra is, it's useful everywhere. Okay, I mean, like industrial computer applications, systems, any, like, pretty much any amount of information can be put into a matrix and played with. And that's why computers use them so much, because they're easy to work with. All right. Now, here's one. So this is only a 2 by 2. So set up the determinant, set it equal to 0, and solve for x. Remember, no. Solve the equation. Don't create your own math. Solve the equation. Raise your hand if you have it. All right, good. So 36 times x minus 12 times 12 equals 0. So 36x equals 144, and x equals 4. Okay? Yeah. Don't try to intuit what a matrix wants to do. Okay? Thank you. You know, maybe after you've worked on them for years, you might have an intuitive feeling for it, but they'll come back to bite you. So now, let's see. About this one. Yes. Oh, the process? Here, let's go back. Um, if I'm doing, you go across the top, ABC, and you knock out that column in that row. And then to do the B, you knock out that column in that row, D, F, H, K. And then for C, you knock out that column in that row, and you get D, E, H, J. That's the process of doing that. So for this one, right, that would be the first term. All you would have to do is plug X back in. Mm-hmm. Yeah. Hmm. Now take the determinant of this. Right? Lots of simplifications. Wind up with some equation for X. Solve for X. Verify that you got here. Okay, so I have 3 little mini determinants to do. Negative 2 times negative 1. Right, but it's, yeah, it's these two minus those two. Okay. It was all under control. That all done?
This is grading. This is not grading. And these are just
Weirdo things.
yeah.
Okay. Where are blanks? Okay. Cool.
Yeah.
Yeah, put this in with that. Yeah, put it with that. And then these, I guess.
Yeah.
Cool. Thank you. All done? Mm-hmm. So, what do we have, right? So, 86? 96? Yeah. Subtraction. Every time. Too much. Waiter, check please. So, that is fair game. Depends on your definition of easy. So now let's tackle something with with some more things and clause. This is just more of the same. You can do this one with me on the boards or on paper, but you're going to go to the boards in a minute. Right. You can make this as easy or as hard as you like, but I'll tell you that if you look and think about this and do a little bit of strategizing about how you can simplify this efficiently, life becomes a lot simpler. What's the first thing that you notice? Got a lot of threes. Yeah, you got some ones in there. You got ones in every position. You got, yeah, yeah, it's bigger than before. But one thing I notice is this situation here. That lets me know that if I subtract those two rows, I'll get a whole pile of zeros, which will be really nice. So, row 1, just like that. Negative row 1 plus row 2 stores is row 2. 1, 1, 3, 4. 4, 2, 0, 0. 3, 2, negative 1, 0. And that makes my life a lot easier. Yeah. Didn't matter. But I didn't want to get rid of the ones. I like the ones. I also see that I've got a GCD in row 2. And things are coming together nicely, actually. Now, we've kind of cleaned this up with only 2 steps. And at this point, you kind of want to stop back, take a look at the landscape, and begin plotting your attack. Yeah.
What's like the goal?
Good question. Okay. It's the identity matrix, because what this is saying is, it's the augmented identity matrix. You're saying 1x equals A, 1y equals B, and 1x equals C. Okay. If you were to think about this as a system of linear equations, you know. All right. So if we're going to plan this attack, we now need to make a decision about what column we're going to kill off. Say it again? Yeah, 2 is nicely able to be destroyed. The problem with 2 is that I don't want to lose that 0 if I don't have to. You know what I mean? Because if I start adding and subtracting onto row 2, onto row 2, that 0 is going to become something non-zero in a minute. Yeah, I like row 3 too. That's awesome. Okay, cool. Let's do that. So let's get rid of this column. Now, I'm going to use the 1 that I have to eliminate anybody above or below it. Okay, that's the process. As soon as you get a 1, use it to kill off everything above and below it and clear that whole column. Okay? And you do that for all 3 columns. Find a way to get a 1, and then multiply and add to eliminate the other stuff above it and below it. So if I'm going to use this -1, 1 and -1 are the same to me. I'm going to use this -1 to kill off that 3. How can I turn that 3 into a 0 using a -1? So this didn't change for now. And so now I've got plus 1 gives me 10. 6 plus 1 gives me 7. -3 plus 3 gives me 0, which was the whole idea. And 0 plus 4 is 4. Woohoo! We have eliminated a column. I can fool with the negative sign later. I don't really care. As long as I have 1s. I'm fine. All right. So now, let's kill something else off. Yes, absolutely. We're going to use the 1 to kill off the 7 and the 2 in the second row. This one's going to go now. Didn't matter what order I did them in as long as I do them. So let's kill off the 7. So what am I going to do to row 2? -7, row 2, plus row 1, stores in row 1. So these other fellows did not change. So now I've got -14 plus 10 gives me -4. -7 plus 7 gives me 0, which was the point. That's still 0, and that's still 4. Yeah, it would be -14 plus 10 gives me. Okay. Yeah. So you see, we're getting closer. Now we're going to keep going and kill off that 2 underneath the 1. See? So -2 row 2 plus row 3 stores in row 3. And so it'll be -4 plus 3 is -1. -2 plus 2 is 0, which was the point. That stays -1, and that's still a 0. Now, I kept all these numbers small so that we're not having to fool with, 36 times 7 plus 48. Oof, no fun. So I'm keeping the numbers relatively simple. So what am I going to do now? Okay. And I'm just going to kill off that sign. And now I'm 2 steps from done. And last but not least, and we're done. And my solution is right there. So this was a simple problem that I hope illustrates the process of killing off a column. First you find a 1. Find a 1 anyhow you can. And then use it to eliminate the items above and below it. And go column by column by column. Sorry. Where? Good catch. And that's when it's useful to check your answers too, Tell me there's not an error in here. Oh wait, there is an error. Right here. There had to be. And there. Take a look. When I used right here, when I added rows 1 and 3, this becomes a -1. See, checking your work helps. And now, doing what I had thought of before, now I feel better. I did it again? I did do it again. Wow. So -2, that should be now a +2. And it'll work because we've made several little clunky little mistakes. Let's take the first row, or take any row. Let's take the 5, 3, 3, 4 one. 5. We're good. So there, you kind of go back to the idea of a system of linear equations. Is, something x plus something y plus something z equals a constant. I just grabbed the middle equation, plugged in my values, and made sure that they really worked. As just to check myself. And if I wanted to be more thorough, I would check it out with a second equation, and my odds of making a coincidental mistake or go down pretty far. Now, there is one last operation that requires no mental work at all, but I do want to show it to you because it is important. It's called the transpose. Has everyone copied this down now? All right. So the transpose just flips the matrix. The transpose? The transpose is used often when you're dealing with sets of data, like honest to God data. Like, for example, if you wanted to multiply two vectors together, like this. And this is actually called the dot product, but we'll talk about that later. In order to multiply these, what I have to do is I have to take the transpose of one of them so that I can multiply them. And now I can multiply them, and I get -6, +12, -6, -9. Yeah, multiply, those two plus those two plus those two, just like we did with regular matrix multiplication. Hopefully that's what you did on your quiz. But yeah, so in a sense, what we have is a way to flip a matrix. It also it's another, for the meantime, for the short term, it's a fantastic way for me to throw another twist on a math problem. Yeah.
So we have how those examples in the first place. Like you can't have to say give like a 3 by 2 or like 4 by 3.
You can't just arbitrarily take a transpose for just because you want to. No, So here, I'm multiplying A times B, and then taking the transpose. And then I'll throw you on the boards. Get some blood moving. Mm-hmm. I could say that this episode of the Bronco Show has been brought to you by the determinants of 3x3 matrices and the transpose.